Day 11,
Hello
Car Audio
and
School.
welcome. Day 11 of your car audio school. This is to teach you how to do your own install, become a technician at a shop, or become a shop manager / own your own business should you choose to do that. This is for educational and entertainment purposes only. This is my online resume of everything that I've learned, and my goal is to help you learn how to do it yourself and stay out of them shops. Congratulations, you have finished section 1. And section 1 was electronic principles. So this is just going to be an overview. I'll give you what we're getting into next, audio fundamentals, but we'll recap high-level overview of what we learned, and then we'll talk about what we're going to go into. So what we learned so far were electronic principles, and that was Ohm's law, voltage, current, resistance, power, series and parallel circuits, Watt's law, understanding wiring diagrams, DC and AC current, grounding principles, fuses, and circuit protection. And then we finish off with battery and charging system fundamentals. We've learned a lot in the last 11 or so days. What we're going to do, because these conversations are getting way more in depth than I planned for, which is a good thing, but they're becoming long form, meaning longer than 5 minutes. It's what I wanted to stick around. But we're getting into 12 minutes, and that's fine. But these next conversations, I'm realizing that to really explain it, I'm going to have to put it on YouTube, and it's going to be like a 30-minute conversation. So what I'm thinking now is on TikTok and Instagram, we're going to do a high-level view of what the subject matter is going to be. And then on YouTube, we'll do a longer form overview where I can get in depth, because what we're about to talk about, audio fundamentals, it's in depth. There's some things that we have to take our time with, and I really want to take my time and teach this correctly. So that's the plan going forward. They will be on I Am Sleepy Digital, and I'm going to start posting things on Nimbus Electronics and Sound. That's going to be the long form. But I Am Sleepy Digital is just going to be the overview, and it's going to be about my electronic escapades. It's going to be fun. But let's get into what we're about to get into. We're going to be talking about audio fundamentals. And this is going to cover sound waves, frequency, amplitude, decibels, impedance or ohms, understanding load and compatibility, speaker types. That's going to consist of coaxial and component. We'll talk about sizes and materials of speakers. And then amplifier classes, which is a big one I think everybody should know about, because we put amps in our cars, but we don't really know what kind of amp we're putting in our car and what it's designed to do. It's just an amp to many people. So in that class, amplifier classes, there's an A class, there's a B class, there's an AB class, there's a D class, and we may talk about some other types of amps also. Power ratings, RMS versus peak. So consistent playability versus peak or maxed out capability. And it could be the difference of a consistent rate of play being 250 watts and then a maxed out 500 watts, but that's in very short bursts. It cannot play that consistently and still be a subwoofer or whatever device it is. Then we will finish off with crossovers, and that would be a passive and active, and then the frequency ranges that crossovers can divide sound into. In theory, there's a high, there's a medium, and low. Specifically, there's a low pass, a all pass, and then a high pass. So we'll talk about those things too. We're doing really good. We're at 6 minutes. So what I'm going to do now is just kind of give you an overview of the audio fundamentals course. And trying to decide which notes I want to use. But we'll probably end up using both. So general overview. I'll use this one. So imagine sound as a ripple in a pond. When something vibrates, it creates a ripple or a sound wave that travels through the air to our ears. These waves have a few characteristics that determine what we actually hear. The main ideas that we're going to be talking about is sound is a vibration. Everything starts with something shaking or vibrating. Think of a speaker cone moving in and out, or your vocal cords wiggling. These vibrations make waves. These waves push the air around them, creating invisible waves that travel through the air, or even water again, or solids. Our ears catch the waves. Our ears are like little receivers. The eardrum vibrates when these sounds hit it. Your brain turns waves into sound. Our inner ear and brain then translates these vibrations into the sounds that we recognize: music, speech, cats meowing, dogs barking, birds chirping, wheels translates into what we know as sound. The key things that make sound different: loudness or volume. This depends on how big the sound waves are. Big waves equal loud sounds. So you can think about a gong, hitting a gong. That creates a big wave, which is going to create a big sound. And then there's small waves equal quiet sounds. So think of a water drop into a pond, and it creates a small ripple out. You can also think of throwing a big rock into a pond. Big ripples equal big sound versus a tiny pebble being thrown into a pond. Small ripples equal quiet. Then there's pitch, high or low. This depends on how fast the sound waves are vibrating. Fast vibrations equal a high-pitched sound, like a whistle, and slow vibrations or low-pitched sounds, like a drum bass, slow vibrations equal low-pitched sounds, like a drum bass. Think of fast, close ripples versus slow, which would be spread out or space in between the ripples. Then there's timbre. So timbre is interesting because it's talking about the quality or the color of the sound. And this is what makes a guitar sound different from a piano. even when they're playing the same note. So think of it, because they're both string instruments. However, a piano string sound will say on the key of C will sound different, even though it's the same note on a guitar playing that same string note. Same thing as a harp or any other string instrument. You can liken it to, we'll say, the color red. And yes, we all know what the color red looks like, but what type of color red? Is it maroon? Is it a rose color red? Is it a stoplight color red? They're all the same red, but they're different frequencies or vibrations of, or tones or colors of red. Just like the unique flavor of a sound determined by the complex mix of different vibrations happening all at the same time. So there's a whole lot of stuff I really want to get to, but we're at 11 minutes, and this is why I have to go to YouTube, because this whole section is a whole other 30 minutes. And it's just the overview, but we'll get into what everything is and what everything means, and why sound is important in car audio. I mean, for obvious reasons, but why it's important. We need to know what's going on so we can make informed decisions on what we put in our vehicles or just decide to purchase. In short, sound is just vibrations traveling as waves to our ears and brain into what we hear. Loudness is the size of the waves, pitch is how fast they vibrate, and timbre is the unique color of the sound. So that's pretty much it for today. If I am to go over certain topics, frequency, amplitude, waveforms, digital versus analog audio, key to audio system components, signal processing and shaping, dynamic range, and that's the contrast between loud and quiet, and then testing and measuring, understanding audio performance, oscilloscopes. We'll talk about real-time analyzers, and that's pretty much it. So we're into the second section of Car Audio School. The first one is going to be an ebook all by itself, but I got to clean it up. And then same thing with this one. This is phase 2, or intermittent. I have to think of what I want to call it. But definitely is phase 2, and then we'll also have a phase 3 and a specialized course where we get into specialty knowledge. So yeah, that's it for today. Links and information on what we're going to get into will be in the captions underneath. And tip your technicians, because this is a lot of information that they need to have in their head. Most of them learn on the job. Very few take the time to get the theory or the schooling part of it down before they enter the job and start their on-the-job training. Donate, donate, donate. We need tools. We need all data. We need Mixer One. We need Direct Tech. And if you have any questions or anything that you want to know or talk about, please put them in the comments. I will answer. And at some point we will go live, so you can call in and we can talk about it. So thank you. Bye-bye.